Okay, so you're not finished yet. We have one more thing to go over about naming substituents. There's one more prefix that we're going to have to put in the beginning of all of those other prefixes that we've been doing. When we have the substituent split, when it splits off at the attachment point, some other carbons go this way, some other carbons go this way, creating its own carbon chain by itself, but at one point it's attached to this parent chain up here. So when we're counting and naming these substituents, there's a whole other set of prefixes that are going to go before all of the other prefixes that I just showed you. They're going to be based on either the shape of the substituent or the attaching carbon of that substituent, the one actually attaching directly to the parent chain. And these are going to be the two qualities that will determine the other prefixes that we use and how we use them. So this is nothing new. We've done these before as examples, but let's compare these and figure out the different ways to name them. Let's just ignore the parent chain for right now. Let's just focus on the substituents themselves, okay? Now, how do you know what to name a substituent? Well, you count how many carbons there are, right? Here's the first carbon, and this is the carbon that attaches to the connecting carbon in the parent chain, which is carbon number 6 in the parent chain. So here is the first carbon in the substituent, the attachment carbon, and then here's carbon number 2, carbon number 3, and carbon number 4. So in the substituent, we have 4 carbons, so we look at our carbon prefixes, and that's bute. And since the substituent, we have to add the ending -yl, YL. So this is going to be some kind of butyl, right? And let's look over here on the right. Here is the first carbon in the substituent, and that's the one that attaches to this connecting carbon, carbon number 4 in the parent chain. So here's carbon number 1 for the substituent, and then this sprawls out like a chicken foot, chicken foot coming out. So this is going to be number 2, and this is going to be carbon number 3, and this is going to be carbon number 4. So this substituent also has 4 carbons in the group, making it also a butyl. Now let's look over here at the bottom to the left. Here is the first carbon in the substituent, carbon number 1, because that's what attaches to the connecting carbon in the parent chain, in this case carbon 5 on the parent chain. So we got carbon number 1 for the substituent, and then carbon number 2 is over here, carbon number 3 is here, and carbon number 4 is here. So this is also a 4-carbon substituent, which means a butyl. Now let's look at this last one on the bottom right. Here is the attachment carbon right here, carbon number 1 of the substituent, which it attaches to this connecting carbon in the parent chain, carbon number 5. So we have 1, 2 on the substituent, and then 3, 4. Again, that's 4 carbons in the substituent, so we have another butyl. But meaning 4, and YL meaning it's a substituent, not the parent chain. Check out how much they look completely different from one another. Like, let's not even worry about the parent groups right now. Just look at these substituents themselves and how different they look. Look at these shapes. This is a totally different shape than this, right? Which is a totally different shape than this, and which is a totally different shape than this. So you get me? So these shapes actually identify what kind of side chain, what kind of substituent, in this case, what kind of butyl group, which totally makes a huge difference in the way that molecule is going to act, and the way that we're going to use that later on in organic chemistry. So let's begin by looking at this one up here on the right, on the very right up at the top. Okay, you see this little chicken foot coming out? That's what I think it looks like. It looks like a chicken foot. This is going to have the prefix tert. So the reason why this little chicken foot is called tert is because of this. So here's the parent chain. Here is the connecting carbon on the parent chain, right? And it comes down and forms a bond with the attachment carbon on the substituent. It comes out in 3 spokes that bond with these 3 carbons. So making this 4 carbons, right? The reason why we call this tert as a prefix for this shape of a butyl group is because we're going to look at the attachment carbon. That's the carbon that is directly attached to the parent chain, right? So this is where the substituent starts. It starts down here at this attachment carbon that's attached directly to the parent chain. This is the carbon we're going to be looking at. Now, how many other carbons in the substituent is this attachment carbon directly bonded with? It's bonded with this carbon out here, right? It's bonded to this carbon right here, and it's bonded to this carbon right here, right? So here is carbon 1 that's attached to our attachment. I'll write this down. Attachment carbon. So attached to that is we have carbon number 1, carbon number 2, and carbon number 3 for the carbons in the substituent, which is directly attached to the attachment carbon, directly bonded. So knowing now that we have 1, 2, 3 carbons directly bonded with that attachment carbon of the substituent, I'm sure you've heard of sometimes when something is number 1 or has one thing, it's called primary. And if it is number 2, it's called secondary. Or it has 2 things, it's called secondary. Or it's like second in line. It could be like second, and this could be first. Well, third or 3 of something is, there's a fancy way of saying 3 also, and that fancy way of saying it is tertiary. So this little prefix tert from tertiary is why we're going to call this shape, this chicken foot shape, tert as a prefix. So how we write that is, well, let's see. We have 1, 2, 3, 4, 5, 6. This is carbon number 6 on the parent chain. So this is where the substituent's coming out. So we're going to write 6 hyphen, because that's where it is in the parent chain. And then we're going to write tert, lowercase. And if you see it in writing, it's in italics, just the tert. And then another hyphen, and then butyl, whatever it is. Let's see if this is 7, 8, 9, 10, 11. Let's just say it's 11. So an 11 carbon parent chain would be undecane. When the attaching carbon is connected to 3 other carbons in that same substituent. So that would be totaling 4 carbons in the substituent, meaning butyl. But that attaching carbon out of the 4 carbons is attached to 3 other substituent carbons. So the 3 other carbons that it's directly bonded to is why the prefix is tert. So since this chicken foot is called tert, meaning 3, meaning that attachment carbon in the substituent is attached to 3 other carbon, how we write this is we write down where this is all going to take place on the parent chain, which is carbon number 4. So that's where the substituent is attached. And then we do the hyphen and then tert in lowercase. And it's also, when it's printed out, you'll see it in italics. And then another hyphen. And this is the only time you're not going to be separating letters and numbers from each other. These are just letters and letters. It's just that these prefixes that have to do with the attachment carbon and the substituent gets hyphenated from the name of its group, which is butyl. And since this is an 8-membered carbon for the parent chain, we would just go on to finish that name octane. So let me write that again. We have 4 from the parent, carbon number 4 in the parent chain is where the substituent sticks out, and it is in tert formation of a butyl group, and the butyl group is the substituent of octane. So see, this is the only time we're going to be hyphenating a word from another word as opposed to a number and a letter, because that's what I've been telling you. You always hyphenate the numbers and letters to keep them apart. This is an exception. This is the only time you're going to hyphenate a prefix and another word when we're using prefixes that are describing what is happening at the attachment carbon in the substituent. Now let's look at the bottom right example. These are all butyl groups. So every single one of these substituents in these examples have 4 carbons, right? So we have, here's carbon 1, carbon 2, carbon 3, carbon 4 in the substituent. Okay, so we know that's 4 carbons, so that makes butyl. And we know the butyl group substituent attaches to the parent chain at the parent carbon 5. So it's going to start with the number 5 because we're establishing where at on the parent chain is this side thing coming off of. And then we want to, say butyl, and this is a 9-membered carbon parent chain, so that would be nonane, right? So we want to be able to say 5-butyl nonane. But what kind of butyl group is this? Because it is definitely not the same shape as the one we just went over, right? It's a different shape. And how is that? Well, okay, so here's the attachment carbon for the butyl substituent, the butyl group. By definition, it has to be the one that is directly attached to the parent chain. And then after the attachment carbon, it goes down to another CH, because see, this has 3 bonds to it, this carbon, and so it's going to have 1 hydrogen. You just imply that. So that would be a CH. And since it makes the chain longer in the substituent, we call them spacers, because it's another space. It makes it go 1 more carbon down the chain. It makes it 1 carbon longer. So CH spacer. So the attachment carbon, the one directly attached to the parent chain, is attached to another carbon, the CH spacer, and then that carbon is the one where it splits into 2 carbons going in 2 different directions. Now in the tert that we just went over, it was that attachment carbon was where the split took place, and these carbons went in all different directions for the substituent. But see, in this case, the attachment carbon is not the same carbon as the carbon where everything splits. Okay, and what you need to walk away with from this is that this splits at the very end of however long the substituent chain is. It's going to be the split at the very end. And I'm going to draw it over here for you, parent chain. Okay, so we have this attachment carbon, and we could just have it split right like that. And it looks like a mermaid's tail or a fish tail. I think mermaids are cooler, so I call them a mermaid's tail. But see how it branches out and splits, so it looks like the end of a fish tail. So here's the fish tail. But we could also have, here's the parent chain. Here's the connecting carbon on the parent chain. Here's the attachment carbon in the substituent. But then we could have another CH spacer carbon right there. We could even have another one. It could go on and on and on and on and be as long as you want. But at the very end, it splits out and looks like a mermaid's tail. Okay, so no matter how long the chain is in the substituent, what makes this a specific thing is that it branches out into the tail at the very end of the chain, the substituent chain. And this shape is called iso. So if we have the carbon chain and this splits at the very end and makes a little mermaid tail, then that is iso. Now, if it's just short, if it's just 1 carbon, the attachment carbon attaching to the parent chain, and that splits into a mermaid tail, it's still iso. Anytime there's a mermaid tail at the end of the substituent chain, it's iso, no matter how long or short the chain is. Now, compare that with what we just went over, tertiary. Now, this tert prefix was given because what was going on at the attachment carbon. Remember, the entire reason why we're calling this tert is for tertiary, which means 3, because this attachment carbon was connected to 3 other carbons in the substituent. And so that's why we call it tert, short for tertiary. 3 other carbons attached to it, 3 other substituent carbons attached to it. We don't worry about the carbon it's attached to up here on the parent chain. So this is different than iso because see, even this one up here that's short, it only branches into 2. It can only be symmetrical and have 1 on each side because that's how you get the mermaid tail. This is not a mermaid tail. This is a chicken foot. And another difference is that if you make a long chain, like, okay, here's the parent chain, here's the attachment carbon. And if you make a long chain and then it splits off into the little chicken foot, that doesn't count as a tert, not tert, because tert is only about what is happening with that attachment carbon of the substituent that's directly bonded to the parent chain. Whereas in iso doesn't really care about its attachment carbon. Like here's this attachment carbon for this one. Iso cares about what is at the very tail end of the chain, which is that little mermaid tail. Okay, so coming back to this bottom right one, we have, here's 5 on the parent chain, carbon number 5 on the parent chain with the connecting carbon, and that's connected to this attachment carbon for the substituent, and then that gives us another carbon that it's attached to, making a chain, and then on that carbon, it splits at the very end of the chain. So since it splits at the very end of the chain, that's the mermaid tail, right? So we know on the 5th carbon of the parent chain, we have the formation with the fish tail at the end of the chain, so that means it's called iso. And with iso, since we're dealing with what's at the end of the chain, the substituent chain, since we're dealing with what's at the end, those prefixes, we can just go isobutyl, and then this has 9 carbons in the parent chain, no name. Now, unlike the 4-tert butyloctane up here, the one we have down at the bottom right, this is classified as an iso shape because it's got the fishtail at the bottom right, at the end of the chain, and it starts on carbon chain, the parent chain, carbon number 5, so hyphen for that. And then when it's dealing with what's going on at the end of the substituents chain, not what's going on at the attachment carbon in the substituent, but what's going on at the very end of the substituent chain, like iso, then you don't hyphenate that before you go butyl. Now let's do the bottom left here, and here is the attachment or the connecting carbon from the parent chain, which is number 5. So we know this name is going to start with a number 5 because that's the number 5 carbon in the parent chain is where the action is taking place. And here is the attachment carbon for the substituent, and these are all butyl, so we know it's going to be 1, 2, 3, 4 carbons in the substituent. But now let's look at this. We have one carbon coming off to this side, and then we have a CH2, and then the N carbon coming off to this side. So we can't say it's iso because iso would have a fish tail or a mermaid tail. Okay, this is not a mermaid tail. This is lopsided. It's not even. And if we just take that substituent as its own carbon chain, okay, I'm taking this just by itself. If we just take this as its own carbon chain and we just number them from end to end, 1, 2, 3, 4, and this is where it connects to another chain, a parent strand, right? Well, our attachment carbon for the substituent is carbon number 2. And as we know, sometimes first means primary, second means secondary, and third means tertiary. Well, if this attaching carbon from the substituent is carbon number 2 out of a 4-carbon butyl group, 1, 2, 3, 4, so it's a butyl. Well, the attaching carbon is carbon number 2, right? So carbon number 2 gives room to give it the nickname based on the word secondary. And so what we're going to do with that is to call it sec. And again, this is about, just like tert, this is about the attaching carbon in the substituent. So sec is going to mean secondary because it's the second carbon that is the attaching carbon to the parent chain in this case. So let's check this out. We have carbon number 1, carbon number 2, carbon number 3, and carbon number 4. And we knew they were butyl already. So this all happens at carbon 5 in the parent chain. So carbon number 5 hyphen, and then we go sec, lowercase and italicized if you're reading it in text, and then butyl, and this is a decane, so butyl decane. And that's what this one is down here. This is a sec formation. Okay, now one more. I saved the easiest for last. Now, if you look at this parent chain, the substituent comes off at carbon number 6 in the parent chain. So carbon 6 is where all the action is going to happen. So we know it's going to start with a 6 hyphen, right? So here is the attachment carbon in the substituent, right? But what happens? Well, it just keeps going in its chain. Does it end with anything special, like a fish tail, a mermaid tail? No. Does it end with a little chicken foot? No. It's just a normal chain with nothing special, no splits coming off of it. It's just a normal chain. So normal gets the nickname prefix of N, and that's it. That's all N means. So this is going to be 6 because it's carbon number 6 in the parent chains where the action is taking place. And then it just goes into a normal chain. It doesn't do anything fancy like split at the end or turn into a chicken foot. It's just normal. So we're just going to put lowercase n and a dash, butyl. And this is an 11 carbon parent chain, which is undecane. So this would be totally normal. That's just a normal chain. So N for normal. Okay, so here is kind of a table I did separating these terms so you know how to spell them and how to correctly write them into the names of the molecules, okay? So on the left, these prefixes are concerned with what is going on at the end of the chain of the substituent. So here are substituents that fan out at the very end of their substituent chain, like a little fish tail or a mermaid tail. And below that, remember the tertiary over here? How it's a little chicken foot? Well, if it's a chicken foot, but it waits to get to the very end of the chain, like there's a long chain before it, and then at the very end, it sprouts out into a chicken foot, well then we're not talking about what's going on at the attachment carbon of the substituent anymore. We're talking about what's going on at the end of the substituent's chain, at the end. So whether it's iso or whether it's neo, both of these are talking about what's going on at the end of the carbon chain in the substituent, end of chain. So the chicken foot, if it's at the end of long chain, then we're going to call it neo. And just like iso, we can capitalize that. We're going to put whatever number the parent chain's on, hyphen, and then neo, and we don't have to put another hyphen there. Like, let's take this one. This is 1, 2, 3, 4, 5, 6 carbons. So that's a hex. So we have to put the hexyl on it because it's a substituent, and then blah, 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 and whatever the parent chain is. So this would be neohexyl. This would not be tert hexyl. Okay, tert is only about when it turns into a chicken foot at the attaching carbon, the carbon that attaches directly to the parent chain, and that's it. And so just like tert is only concerned with the attaching carbon that attaches its substituent to the parent chain, just like tert, sec is the same thing. Sec has to do with the, let's see, here's 1, carbon 2. Sec has to do with the fact that it has to be carbon number 2 on the substituent chain that attaches to the parent chain directly. It has to be carbon number 2. So that's why sec for secondary. So these are all about what's going on at the connecting carbon or the attaching carbon. So sec, lowercase, and you hyphen it, and it's in italics if you read it. Same thing with tert, lowercase, hyphenate, italics. Oh, and you have to hyphenate it beforehand because this is the number of the parent chain. Number of the parent chain, hyphen, and then sec, or number of the parent chain, hyphen, and tert. And then hyphen before you get to, you know, butyl undecane or whatever the parent chain is. So if it's dealing with the shape at the end, then it's capitalized and it's not hyphenated. And once it does that, since we're turning it into like isobutyl or neobutyl, that becomes part of that word. So when there's one extra step, when I was showing you when you have more than one substituent and you're naming the whole molecule and you have to alphabetize the substituents, you actually use these letters to alphabetize. No longer are you using the B in butyl to alphabetize the butyl substituent. You're using the I, because since these don't get, the ones dealing with the end of the chain, the end of the substituent, do not get hyphenated. They blend right on in with the rest of the name of the substituent. So they are the ones that get alphabetized. Whereas these that are just dealing with the attachment point of the substituent gets hyphenated. And so they don't ever really become part of the actual group word. See, tert, butyl, something, something. And so when you're using that with a hyphen, then you go ahead and use the B in butyl to alphabetize that substituent with B.